In this video, I will show you how to solve for single period inventory models using POM/QM. So for example, in the past videos, I have shown you or we have reviewed how to solve for inventory control problems or EOQ when demand will continue into the future. In other words, there will continue to be demands, and so the company or entity will continue to place orders for the same product. But what if there is no certainty about future demand, and therefore, the decision to meet demand is for a single time period only. Yeah. So this would apply to situation where items that do not sell during that time periods will have no more value, and so really there is no future market for that product. Let's say a newspaper. Once we have gone past the day, normally there is no more selling value for the newspaper that are produced in that day. Or for example, certain kind of food that are made, once it has passed a certain time, it expires, and so the demand for that specific unit produced is the market is done. We call this single period inventory model. The way to do this is we can use marginal analysis as the analysis to make the decision of whether to continue making or ordering an additional unit. And so we use marginal analysis that involves marginal profit and marginal loss. I'm not gonna show you the manual way of doing it. You have the capability of reading and studying it here in the textbook. It's pretty straightforward. But what I'll do is I will show you how to solve this using POM/QM. So basically, continue to, let's look at a few parameters here. Yeah, P would be the probability that the demand will be greater than or equal to a given supply. Yeah, so P is probability that demand will be greater than or equal to a given supply. In that case, you will want to sell additional unit. Why? Because the demand is greater than your supply. 1 minus P is the probability that demand will be less than supply. Or, in other words, we call this the probability that one additional unit will not sell. So P is the probability that the probability of selling at least one additional unit, and 1 minus P is the probability that one additional unit will not sell. Okay, the expected marginal profit is found. Expected marginal profit is found by multiplying the probability that a given unit will be sold by the marginal profit, P multiplied by MP, and expected marginal loss is the probability of not selling the unit multiplied by marginal loss. So 1 minus P, that's the probability of not being able to sell additional unit, multiplied by the marginal loss. So what is the optimal decision? This is the decision where we need to stop. Do we sell additional unit or do we stop? The optimal decision rule is when the probability of marginal profit is greater than or equal to the probability of not being able to sell additional unit multiplied by the marginal loss. That's the point where you continue to sell additional unit. But if probability of marginal profit is lesser, then probability of unable to sell additional unit multiplied by the marginal loss, then we need to stop. Okay, so I mean, those are some terminology, some concepts. Let's look at an example immediately. There are two approaches to this. We use discrete distribution and we use normal distribution. In discrete distribution, here are the steps. Determine the value of marginal loss divided by marginal loss plus marginal profit. Construct a probability table and add a cumulative probability column. So this is the probability distribution. We need to construct another table with cumulative probability column, yeah, on this side. I'm going to show you table 6.7 is that. Table 6.7 is a table in which we have added the cumulative probability distribution. Yeah. At that point, the cumulative probability distribution is 1. At that point, at 5, selling 5 donuts, the cumulative probability distribution is 95% because that is 1 minus 0.05. 0.95 minus 0.15 is 0.80 and so on. Yeah. I'm not going to go through the manual process here. I'm going to show how to use POM-QM to solve this problem. Let's look at an example here for Cafe du Donut example. This is a donut shop in New Orleans. It specializes in coffee and donuts. The cafe pays $4 for each cartons containing 2 dozens of donuts. They're delivered every morning. Any cartons not sold at the end of the day are thrown away. Why? Because they're going to be bad. They would not be fresh enough to meet the cafe standard. If a carton of donut is sold, if a carton of donuts sold, the total revenue is 6. So basically 6 minus cost of 4, that gives us a marginal profit of 2. The marginal loss, if a donut is not being sold, there is no revenue. They have paid or they've spent $4 for each donut, and the marginal loss is $4. Okay. Since the donuts cannot be returned or salvaged at the end of the day, yeah, it's a marginal loss also 4. From past sales, cafe manager estimates that the daily demand, yeah, so from past history, the cafe manager estimates that daily demand will follow the probability distribution in table 6.6. Here is an example. They'll be selling 4, 5, 6, 7, 8, 9, 10. Based on history, there's a 5% probability of selling 4, 15% probability of selling 5, 15 probability of exactly selling 6. But those are exact probability. Probability of exactly selling 4 is 5%. Probability of exactly selling exactly selling 5 is 15%. Exactly selling 6 is 15%. Exactly selling 7 is 20%. That's the exact probability. But what we need to do is we need to develop the cumulative. We need to develop the cumulative probability column. So we go to table 6.7. Here the cumulative probability table is developed. So by selling 4, we have 100% probability of selling 4 donuts. When we bring it up to 5, there are 95% probability of selling up to 5 donuts. The probability of selling up to 6 donuts is 80%. It's basically 100 minus 5 is 95. 95 minus 15 is 80%. Probability of selling 7 donuts or less is 65% because 80% minus 15%, that's 65% and so on. So this is the cumulative table. And then the last step is keep ordering inventory as long as the probability of selling at least 1 additional unit is greater than the probability of not being able to sell additional unit. This one. This is the cutoff point. I'm going to show you how we build this into POMQM. Okay, so I'm gonna say new. I'm gonna say reorder point, actually here. I'm gonna say single period inventory discrete distribution. This is a discrete distribution. Okay, what are we gonna use? We can use marginal profit and marginal loss. How many demands? We have 1 demand, 2, 3, 4, 5, 6, 7. We have 7 levels of demand. So number of demands 7. I'm gonna click OK. Okay, now here, what is the marginal profit per unit? The marginal profit is 6 minus 4, that is 2. The marginal cost per unit is 4. Okay, what is the demand? The demand starts with a 4, a 5, oops, that's wrong. A 4, a 5, a 6, a 7, an 8, a 9, a 10. And the probability distribution based on history is 0.05, 0.15, 0.15, 0.20, 0.25, 0.10, and 0.10. Okay, once we're done, we click solve, and it solved it for us. You see, this is the cumulative probability. Let's look at table 6-7. Yeah, 1, 95, 80, 65, 45, 2, and 1. Now, see, the cutoff is 67%. That is when we hit a cumulative probability of 67%, this is the probability that we will not be able to sell additional unit. What does it mean? If we can sell additional unit, that means it's a loss, it's a marginal loss. So what is the probability of having a marginal loss? The probability is 67%. So we should continue to buy or to order additional cartons of donuts only up to the point when there is a marginal probability of not being able to sell 1 box of donut. And that probability is 67%. So what is that? Look at the cumulative table. Sorry, look at the cumulative probability column. When we sell for, if we order 4 cartons, the probability of selling that is 100%. When we order 5 cartons, the probability of selling all 5 cartons is 95%. When we order 6 cartons, the probability of selling all 6 cartons is 80%. How do we know this? You know, the total probability is 1, right? 1 minus 5%, it's 95. 95 minus 15 is 80%. So at 6, at the point of ordering 6 cartons, the probability of us being able to sell 6 cartons are 80%. Yeah. When we say, what about if we order 7 cartons? The probability of us selling all 7 cartons is only 65%. And the probability of selling all ordered donuts is 65%, and it's lower than the probability of loss from an additional carton. So really, because it is lower, we should not order 7. We should only order 6. You see, 80% is greater than the cutoff point. The cutoff point is the marginal probability of having a loss from a single carton. So at 80%, at six carton, we still have probability of being able to sell everything, 80%. It's greater than the cutoff point of 67. So what is the cutoff point? We should stop at 6 cartons. Okay, and you can see here the decision is the optimal point, the optimal stocking level is at 6 cartons of donuts. Okay, that is discrete probability. So I will stop there. I will continue this recording with marginal analysis with normal distribution.